So I'm going to go through the same properties of exponents that we looked at in class. So whether you missed notes or you just needed some things re-explained, you wanted to see some more examples, this is just going to sort of go through those same properties that we took a look at. So we're talking about exponents. Some basic things that we need to know about exponents are just some basic terms. So we need to understand that we sort of have three different things that can be happening when an exponent is involved. Okay, we can have the small number up here, which is our exponent. Okay, we have whatever number or variable is going to be receiving the exponent, and that's what we call our base. And then we also potentially could have a number in front of it, and that's what we call our coefficient. Okay, so when we're looking at our properties of exponents, these are all terms that are going to come up that we need to know what we're talking about to be able to simplify and do operations with properties of exponents. So the first property that we're going to take a look at is addition and subtraction, or how do we add or subtract when exponents are involved. Now, this is something you've actually been doing for a long time. You just never really realized that it involved exponents. So when you've been combining like terms, or maybe you've been dealing with something like 4x plus 2x, okay, this is actually involving exponents. And the reason why is that everything has an exponent. It's just that sometimes we don't see it. So if we just see the variable x, okay, we already know that this has a coefficient of 1. Okay, but we also know that even though we don't see it, there's also an exponent of 1 happening there. So when we're looking at 4x plus 2x, we're actually looking at something that says 4x with an exponent of 1, 2x with an exponent of 1, and we know that 4x plus 2x gives us 6x, or 6x with an exponent of 1. Okay, so we started with something with an x to the first, we added it to something with x to the first, and we get an answer of something with x to the first. So if that exponent changes, the rule is going to stay the same. So maybe if I have something like 7x to the third plus 3x to the third, okay, I'm still going to take that 7 plus the 3, which gives me the 10. And then my label is going to stay the same, or my exponent, which was a 3 and is added to something with a 3, is going to continue to have an answer of something with a 3. So our rule when we're adding or subtracting exponents says that we are going to add or subtract, depending on what sign we see, the coefficients. Remember, the coefficients are the big numbers in front. So we're going to add or subtract the coefficients, the numbers in front, just like we've been doing, right? So 7 plus 3 is 10. That follows the operations we've always known. Okay, and then we are going to keep the exponent the same. So if it started as a 3 and we added it to something with a 3, then our answer is going to be something with a 3. Now, all of this is based on the fact that the base must match and the exponent has to match. Okay, so we can't add something with an exponent of 2 to something with an exponent of 3 because those don't match to start with. Okay, we can't add an x to a y because an x and a y are different variables. Okay, so we need our base to match and we need our exponent to match, and then we just keep, add the big numbers in front and we keep the label the same in the end. So if we look at a couple examples here, just to make sure good. Right, if we have 5y to the 5th minus 3y to the 5th, okay, we're going to subtract the big numbers in front because that's the operation we see. So 5 minus 3 gives us 2. And then it was a y to the 5th. We combined it with a y to the 5th, so our answer is going to have a y to the 5th. Okay, maybe if we have 4w squared plus a w squared. Okay, same rules that we've known in the past, right? We don't see a coefficient here, which means there's really a 1, right? So this is going to be 4 plus 1, which is 5. And again, our base and exponent are staying the same, so we'd get 5w squared. Okay, the next property that we're going to look at is what do we do when we have two exponents happening? Okay, so this is often called the product to a power, or a power to a power, or product of a power. I'm just going to sort of throw them together in the same combination. And what happens when we have an exponent that's being taken to another exponent? What happens when we have two exponents happening at the same time? Okay, or what happens if we have something like x to the fourth all to the third power? Okay, so in this situation, if we have an exponent to an exponent, we are going to multiply the 4 and the 3. So 4 times 3 gives us 12. Okay, and we'd get x to the 12. Now again, just like in addition and subtraction, if there's a coefficient in front, okay, we are going to give the exponent to the coefficient, and we'll calculate that just like we do any exponents. So if you're using a calculator, you'd use your up caret button. Okay, but we'll calculate that just like we would any exponent. Okay, and then we're going to multiply the exponents. Okay, so if we have w to the fifth, all to the seventh, right? We have two exponents happening, so we're going to multiply those and we'll get w to the 35th. If we have something like 3y squared, I don't know, all to the fourth. Okay, so if we have multiple things happening in here, it's kind of like the idea of distributing. Okay, we're just sort of passing out an exponent where we're going to give this exponent to each of those pieces. So not only do we need to multiply these exponents, okay, and get that y to the 8th, we also need to give that exponent over here to the coefficient, and we need to calculate 3 to the 4th power. So you have a couple options if you want to calculate 3 to the 4th power. You can either take 3 times 3 times 3 times 3, or in your calculator, you're going to type in 3 and then the up caret button. So the up caret button is sort of diagonal, and then above this, diagonal to the 7 and a little bit up, it looks like two sides of a triangle. So you would type in your calculator 3 and then the up caret button and then 4. And it will tell you 81. And so we'd get 81y to the 8th. Okay, so it doesn't matter how many things are happening inside there. So even if this was maybe more like a fraction, right, that idea is still the same, that we're sort of going to give this exponent to each of them. Or again, these will get multiplied. These will get multiplied. But we still need to give the exponent over here and multiply it like we normally would. So we need to take 2 squared, which is 2 times 2, and get 4. Okay, the last property that we're going to add to our list today is what do we do if we are multiplying with exponents? So if we have something like y to the 5th times y squared. Now, if we're multiplying with exponents, we are going to take these exponents and we're going to add them. Okay, so if we have y to the 5th times y squared, we're really going to add those exponents, which will give us y to the 7th. And just like the other explanations, if there's a coefficient in front, it's functioning under the operation it always has. So we're going to multiply the coefficients, multiply the big numbers in front, just like we always have. Okay, and then we are going to add the exponents. Okay, we can only add the exponents if the base matches. X's and Y's can't go together. Okay, so if we have something like 3x to the 4th times 2x squared. Okay, the coefficients, the big numbers in front, we're going to multiply like normal. So 3 times 2 gives us 6. And then we're going to add the exponents. So 4 plus 2 is 6, and we'll get 6x to the 6th. Okay, we have more things going on. So maybe 2xy to the 3rd times 5x squared y. Okay, so if we want to multiply these, we're going to also add the exponents, but we'll sort of see on a couple of these variables the exponents aren't there. So we sort of need to fill in the number, or at least remember that when we don't see an exponent, there's really an exponent of 1 happening. Okay, so we'll take the big numbers in front, the coefficients, we'll multiply those. So 2 times 5 is 10. Okay, and then we're going to take the pieces that have the same base. So the x's I can put together. So 1 plus 2 is 3. And then the y's I can put together. So 3 plus 1 is 4. Okay, so our rules say that if we're multiplying with exponents, we're going to add them. If we have 2 exponents happening, we are going to multiply the exponents. And if we are adding or subtracting with exponents, we are going to keep them the same.